Man, I wish I had a simpler, faster, and more flexible programming language. Wait, what is that? Go was designed by Google at 2007. It was publicly announced in 2009 and it was released to the public in 2012. People say that it was born thanks to the stubbornness and hate developers had against C++ and the trouble Python made by being slowed and dynamically typed. Go has been used in very important projects, just like Kubernetes and Docker, two of the most used complementary software technologies we have until this day. They are used for packages and specifically making containers.
Every executable Go program starts with a package. Here we have package main, which tells Go that this is the main package of our program. Then we can import packages that provide functionality we need. For example, fmt allows us to print information to the console. The program starts executing from the main function. Functions in Go are declared using the func keyword, followed by the function name and the parentheses. Inside the function, we can use fmt.println to print a message, so even a basic Go program can be written in only a few lines of code. Go allows us to explicitly declare the type of a variable. For example, this variable, John, is a string. But Go can also infer the type automatically. Using the short declaration operator, we can simply write x equals 2, and Go understands that this is an integer. Or we can use another structure just like var student equals Jane, and it will infer that it's a string. Go also provides the usual control structures, such as conditional statements, in which comparison operators and logical operators are used. These ones are the same we use in Java.
As we have seen, Go is a small yet powerful language that compiles pretty fast, and even though it doesn't contain some data structures, not so much of a variety of them, we can still create one with the struct or the object class. So we are going to create a linked list. Let's see it. First, we gotta understand what is a linked list. So in a linked list, we will have a node that is a little element that saves some information and a pointer. The pointer by default is going to point to null, but if we want to have a linked list, what we are going to do is link every node with the next one. So we create some nodes, every one of them will hold data, and every one of them will have a pointer to the next. If we wanted to make it a circular list, we will do that the last element points to the first one. But in this case, we will leave it that the last one just points to null. And the first element we are going to call a head. We save that head in the linked list, and that's what we define. This right here is our friend from Go, that little mascot. So let's get into what we do with Go. We use struct to create what in Java will be a class. So we will create a node and a linked list. We just use the struct to define those objects inside of Go, and what we are going to save in them is, in the case of the node, we save the information, the data it has, and we save a pointer to the next. And in the linked list, we just save the head and we put methods to make operations between. Now we'll be able to understand the code. Let's get into it.
You wanna hear a secret? Data structures are great. You should try them.
So let's dive into creating a linked list in Go. We install Golang, an IDE powered by JetBrains, and start to code. We create our custom node and a linked list using struct like we explained before. Let's start creating the functions. We have an insert first, in which we create a node that points to the head and we make that node our new head. With insert last, we find our current last node and we insert there a pointer to the new node. We have a little error right there because in the last node we just created, we put a pointer to the head, so it made it a circular list. We'll see how that affects the list. With remove first, we just take the next node to the head and we make it our new head. The old head is going to be handled by the go garbage collector, so it won't leave unnecessary space wasting on our memory. For remove last, we just find our second to last and tell it that the next one is null. That way we delete the one that was actually our last. Then we have the function to print a list. We're going to see that one later. Sometimes we might need a single element of the list instead of printing all the list together. So we make a pop. In this case, because it is a linked list, we could also get the n element, like in any position we want, but in this case, just for facility, we'll keep it for pick and pop. In this case, taking just the head, so the complexity is O of 1, and we just take the head in pick, we print it, and on pop, we use that same method from pick, and we also delete the head. That's the difference between those two. Finally, we make our print list, and now we're ready to make some tests of the list in the main. So first we're going to fill it with some characters using rune, so that we get here. We put first A, and now it starts summing rune of 0, rune of 1. So what that's going to do is create the next character. So we have A, B, C, D, all the way to the F, or depending of course on the number we use on the for iteration. And when we print the list, we are going to see all those characters in the reverse alphabetic order. Have in mind that the null or nil that we print is not a part of the list, but we put it there because it's how the nodes work. Of course, the last node is going to be pointing to null. So we also see right here how it crashes when we don't put that pointer in null. So we go up there, we fix the error, we put it pointing to null, and now the list has an end. We also tried the pop and pick that print the head of the list, but in the case of the pop, it also deletes it. That's all for today's demo. I hope you like it and start using Go.